Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is check completeness of a binary tree. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking? That you need to state whether it is a complete binary tree. What do I mean by a complete binary tree? Is that all the levels are filled, and in the last level in the last level every left should be filled first. What do I mean by that? Let's make a tree. While filling it, left will be filled first, then right, then again left, then right. Let's take another example. This, without filling it, we filled this and this. This is not not a complete b tree, binary tree. We have to fill first left. It's a necessary condition in the last row of complete binary tree. So that is the question. We have to state true or false whether it's a complete binary tree or not. And for complete binary tree, every level is filled except last, and in last this condition has to be true, that left is filled first then right. And that's it. So how we gonna approach this? Very basic, intuitive is we are checking that this parent has left or right or not. For this level, first we check for this level, has all the child, not he has all the child present or not. And again we check for this, he has all the child present or not, he has all the child present or not. So we ask this question level by level. So level order traversal, the BFS, the breadth first search, that's we are doing. Let me again repeat it. Why we are doing it? Because in every level you have to ask the question, are you filled or not? Do you have all the childs? I mean two childs, it's a binary tree. And in the last level you have to see that left is filled then right, and that's it. I think that is clear, that you are asking from the level, so that's why at every level you make decision. So that's why level order traversal, most intuitive way to think about this. So how we gonna approach this? Only case that we have to handle is this. If this happens, why? Because if we make this tree na, this is a complete, even if this is also complete. So if there is a null and something appear after it, what does it mean? That it's not a complete binary tree. Am I right or wrong? Complete b tree. Let's take this case. For the very first time, when the null will appear, will something appear after this? No. So what it is? Complete. Even if we take this case, something is appearing after null, it's null only. So what it is? Complete binary tree. So that is the case, this is the case that we have to handle. if something appears after this and something means some value, so or some node appears, so that case tends to a not complete binary tree. So this much is pretty easy. What would be our algo? Algo would be basically BFS. Let's discuss the code only. Video will get longer. Let's discuss the code only. The very basic thing, as we are doing BFS, queue has to be made, and queue of which type? Tree node type, because we are storing the nodes. That much is understandable. Pushing the root, and this is what I was talking. Previous is true. I made previous true. Let me explain further, then you will understand. Basically, I made this as a marker. If null appears and something appear after the null, that it means what it means, that it is not a complete binary tree. You will get it. I will also dry run it. You will get it. So just basic thing, taking out of it queue, popping the queue, and see if the node is null. And what we do is previous is equals to false, that we have encountered null. It's a case to worry now. And again, what we do is, if it was not null, we check that previous was null or not. If it was written false, nothing should be done. And if that was not the case, if it was not false, so just push the left and right child, nothing else. And also, why this works, if you do a standard way of BFS, you always put a check of something like this: if left is not equal to null. We are not going to do this. Why? Because for the same reason, we want null. Null will be our indicator that something has happened. We have to look into it. So that's what we are doing. Let's get the code. Where is the code? Let it minimize. Let me get the code over here for the dry run, so that more understanding can be made. Yeah, it is easy, but why to take chance? For someone it may be easy, for some it may not. So nothing to worry, I will discuss everything. Let's take that false case only, then you will understand. Let's take this case only. Let me snap it also. Yeah, let's take this case. 1 2 3. You can see yourself. Let me have another color pen. You can see yourself that left is not filled first but right. So 4 5 7. First root is pushed. This is the queue. Root is pushed. What is the root? 1. There will not be 1. There will be a tree node type, but for the representation I'm doing it. Previous is true. This is popped. Here popped. What we do is the previous null. We check. No. What we go over this block. What we do is previous null. No. What we do, push the 2 and 3, left child first, then right child. Again for 2, popped. What do we check? Does previous not does? Is previous null? No. What we do? We again come to this block. We push its child. We check for 3. Is the previous null? No. We again go to this block. What we do? We again push it. Null and 7. So 4, we take out 4. Is previous null? Not previous, node. Is node null? Is node null? No. Is previous null? No. Sorry if I used previous somewhere. I am talking about node for the first time. If node is null, I am talking about 4. 4. Is node null? No. Is previous null? No. Does he have left and right? No. Null, null. 5. Same case happens. Null, null. But does node is null? Yeah, it is. Previous is false. Yeah. Then we, in other iteration, we pop this. We go to this. 7. We go to this block. Was previous null? Yeah. What should we do? Return false. So this is how our code is working. Let me repeat it again. If I missed use the word previous, let me repeat it again. Yeah. Let me repeat it again. My bad. For the one, we check is node null. No, node is null, not null. We go to this block. We push its right, left and right. Left and right. Node null. No, 2 is not null. Previous null, not null. We pushed its left and right child. For the 3, is node null? No. Push its left and right. And also is previous is not null. Null and 7. We take 4 out. Is it null? Is it null? 4 is not null. It's previous null. No. What we do? Push null, null, because 4 doesn't have anything. Null, 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 null. For 5, what we do? Same thing. Null, null. But this time node is null. What we do? Previous is equals to false. Previous is now false. We have encountered in the history or in the previous node, we encountered false. Now when we iterate for 7, this time 7 is not null. We will go to the else part. Is previous false? Yeah. What we do? Return false. So that is the case. I hope I was able to make you understand my intuition. Let's submit it and see if it is running or not. Yeah, it is running. So I hope I was able to make you my intuition clear to you. So you have to do what you have to do. So keep grinding. You guys are awesome. See you in the next one. Bye bye. And also, if this video made some sense to you, so consider subscribing and liking this video and sharing with our friends. So see you in the next one. Bye bye.